Hello everyone, let's do the applications of Newton's laws. Let's just consider forces to be constant. And before solving a specific problem, let me give you these helpful tips. It is very useful if you follow these following steps in solving a problem. First, you need to isolate the body being considered, and then draw the FBD or free body diagram for each isolated body, showing all the external forces acting on it, and then determine the summation of force or the if net using the FBD or the free body diagram as a guide and equate to either 0, so meaning summation of force equals 0 for the first law, and summation of force equals MA for second law, depending on the problem. And sometimes kinematic equations are required in solving the problem, so you can use the kinematic equations. Let's apply Newton's laws in solving this given problem. A suspended 5 kilogram mass is pulled by a force along a horizontal, making an angle of 30 degrees from the ceiling as shown in the figure. If the mass hung motionless in the setup, determine the magnitude of the force and the tension exerted by the string. So we have in here a given mass suspended by a string, and then because of the force pulling horizontally, the string makes an angle 30 degrees with respect to the horizontal. And of course, there is also a tension force exerted by the string in our given mass. So the first step to solve this kind of problem is to determine the FBD of the given mass. Applying the hint given to you in our previous lesson, mass is given, so therefore, the force of gravity will pull the mass downward. So by this force equivalent to its weight. And another force, of course, the force exerted in pulling horizontally the given mass. And another, the force exerted by the string. So if this is 30 degrees along horizontal, this is equivalent to the 30 degrees also in here. So this is our FBD. First question is to determine the force exerted and also the tension. Let's consider first the tension. Summation of force along vertical or Y. This is equal to, so what do you think? Is it 0 or MA? Take note that our system hung motionless. So therefore, there is no motion. So definitely it is equal to 0. So it's first law. First law, case A. Okay. So what are the forces? So we only have Ty, meaning the component of T along y-axis. Of course, the Tx is horizontal, so this is not included in our summation of force along vertical. And also the F, the F is along horizontal, so therefore F is not included in our summation of force along vertical. So we only have T and W. Our Ty is positive because it is upward, and then our W is negative. So if we add, we have component of T along Y, and then minus the weight, and this is equal to 0. The Ty is just equal to T sine theta minus W is mg, or the mass times the acceleration due to gravity, and this is equal to 0. Therefore, our T sine theta is equal to mg, transposing mg to the other side of the equation, and solving for T, this is equal to mg over sine theta, or substituting the values, we have 5 kilograms times 9.8 meter per second squared over sine, what is the angle? 30 degrees. So this is equal to, our tension is equal to 98 newtons. So this is our answer. The next question is to determine the force F. Our force F is located horizontal. Let's also do the summation. Forces along horizontal of all the forces acting on our mass. So is this equal to 0 or ma? Again, motionless, so this is equal to 0. There's no acceleration. So this is first law case A. So what are these forces? Let's now identify the forces. Horizontal, so we only have two forces, the F, and again, that component of T, but this time along horizontal, or this is equal to Tx. And W is not anymore included since W is perfectly along vertical axis. So we only have F, positive, then minus the Tx since our Tx is towards the left. So we have Tx and then equal to 0. So force now is equal to the Tx, or this is just T adjacent cosine of our angle theta, 30 degrees. So we know the value of T. So T is equal to 98 Newton cosine 30 degrees. So our F is equal to 87 newtons. So this is our magnitude of force directed along horizontal.